because of the variation of current in the neighboring coil, the EMF will induce in one coil, and that is called as mutual inductance. Self-inductance means the phenomenon in which the EMF induced in one coil due to the varying current in the same coil. The energy stored in the coil or in a solenoid, it is given by U is equal to Li square divided by 2, or it can also be written as half into Li square. Hello everyone, welcome to session 2 of chapter 6 Electromagnetic Induction. This is Swati from Department of Physics, Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. In this session, let us learn about the concepts of induction. What is mutual induction? What is self-induction? What is AC generator? What are its uses? And many more. So let us start with inductance. What is the meaning of inductance? We know about capacitance, we know about resistance. Similarly, we have a term called inductance. What is its SI unit? So, induction or inductance of a coil is the magnetic flux. Magnetic flux means number of magnetic field lines passing through the surface. So, inductance of a coil is the magnetic flux linked with the coil per unit current, which means magnetic flux is given by phi B divided by current I. So, phi B by I is nothing but an inductance. It is the ratio of magnetic flux to the current. The SI unit of inductance is Henry, or it is denoted by a symbol capital H. So, now after knowing what is inductance, we have to know about two important terms in EMI, that is mutual induction and self-induction. So, what is mutual induction? Or the question may be like this: define mutual inductance between a pair of coils. Mutual means we must have a source and a coil. So, because of the source, there will be an induced EMF in a coil, what we can observe. So, in simple terms, we can explain the mutual induction as the phenomenon in which an EMF is induced in one coil due to the variation of current in a neighboring coil. So, that neighboring coil acts like a source. Because of the variation of current in the neighboring coil, the EMF will induce in one coil, and that is called as mutual inductance, or it can also be defined as the ratio of magnetic flux linked with the coil to the current in the neighboring coil, because phi B is nothing but the magnetic flux and I is nothing but the current. Due to the variation of current in one coil, there will be a change in magnetic flux, or an induced EMF can be observed in another coil, and we will call it as mutual inductance. Next important term is self-inductance. So, what is self-inductance? Self means within. So, self-induction is the phenomenon in which an EMF is induced in a coil due to a varying current through the same coil. There is no any neighboring coil to help in inducing the EMF. So, if that is the case, then it will be a mutual inductance. Self-inductance means the phenomenon in which the EMF induced in one coil due to the varying current in the same coil, and it can also be defined as the ratio of magnetic flux linked with the coil to the current flowing through the same coil, or it can be given by d phi B is directly proportional to L, or phi B is equal to L into I. So, equating this equation, we will get phi B is equal to L into I, where L is nothing but the self-inductance and I is the current. Let's move on to an important derivation, that is an expression for energy stored in an inductor. So, energy stored in an inductor which is carrying a current. So, it may be a coil or it may be a solenoid. So, for that, we have to consider an inductor. What is an inductor? It's a device which is having a self-inductance. So, the self-induced EMF always opposes any change in current in the circuit, and hence it is also called as back EMF. Why it is called as back EMF? Because the self-induced EMF, it will always oppose any change in the current in the circuit, and hence it is defined as back EMF. So, the work which has to be done against this back EMF in setting or in establishing the current. So, this work done will be stored in the form of potential energy, and we will call it as magnetic potential energy. So let us consider a small amount of work done, that is dW be the work done in establishing a current in a coil in time dt. So now what is the rate of work done? The rate of work done is dW by dt, which is equal to E into I. But what is E? It is EMF, that is self-induced EMF, which is given by L into di by dt. Now we can replace this equation by this terms. So we will get dW by dt is equal to L into di by dt. We have one more I here, so writing the same. Now dt can be cancelled directly, or you can write one more step, dW by dt is equal to L into I into di by dt. Now dt can be cancelled and you will remain with dW is equal to L into I di. dW is amount of work done, that is a small amount of work done. To get the total amount of work done, we need to integrate this equation. So integral of dW gives us total work done W, which is equal to integral of L into I di. Here self-inductance is a constant, so we have to integrate only the varying current I into di. It is of the form integral of x dx, which is nothing but x square divided by 2. So now we will get L is constant, we are integrating I into di, so we get I square divided by 2, and our equation becomes W is equal to L into I square divided by 2, and this is the work done, or this work is stored in the coil in the form of energy. So the energy stored in the coil or in a solenoid, it is given by U is equal to Li square divided by 2, or it can also be written as half into Li square. So this is the expression for the magnetic potential energy, which is nothing but the work done which is stored in an inductor. Let us move on to another concept and the last concept of this chapter, that is AC generator. What is an AC generator? So an AC generator is a device which converts the mechanical energy into electrical energy. An AC generator basically works on the principle of electromagnetic induction. You can observe this is the schematic representation of AC generator, where we have a magnetic field which is produced by two poles of magnets, and we have a coil, we'll call it as armature, which will be rotated in its axis, and it is connected to an external circuit with the help of two slip rings. So we all know that it works on a principle of electromagnetic induction, which means as the coil rotates in magnetic field, the flux change occurs and it induces an EMF. So if the EMF has to induce in any circuit, there has to be a change in its flux. Change in its flux means change in magnetic field lines passing through the circuit. So as the coil rotates, the flux change occurs, and because of that, EMF will induce in a coil. Let us know about the construction and working of AC generator. It consists of a coil called armature, which is placed in a magnetic field B. So this coil can be rotated in its axis, or it can be rotated on an axis which is perpendicular to magnetic field. So when the coil is rotated, the angle between the magnetic field and its area changes. So when the angle changes, the magnetic flux linked with the coil also changes. Because of change in magnetic flux, there exists an induced EMF in a coil. And the ends of the armature or the coil are connected to the external circuit with the help of slip rings. These two are called as slip rings. Let us now learn about the theory of AC generator. So let us consider A be the area of the coil, and B is the magnetic field in which the coil is placed, and N be the number of turns in the armature. So theta be the angle between area vector and the magnetic field B. So if it is rotating in a magnetic field, omega be the angular speed. So it is changing its angle. The angle between the area of the coil and the magnetic field are changing when the coil rotates. So omega is the angular speed, and we know that omega is nothing but theta divided by t, that is angular displacement divided by time. So from this we can write theta is equal to omega t, which we are using in the further substitutions. So the magnetic flux linked with the coil is given by phi b is equal to b into a cos theta. But what is theta? Theta is omega t, so our expression becomes phi b is equal to ba into cos omega t. So we know that from Faraday's electromagnetic induction, so the induced EMF for the rotating coil of n turns, that is EMF, is given by E is equal to minus d phi by dt. If a coil is having n number of turns, then E is equal to minus n into d phi b divided by dt. In the place of phi b, let us substitute these terms and we get E is equal to minus n d by dt of b into a cos omega t. In the place of phi b, I am substituting b into a cos omega t. Now we can group these terms. We can differentiate only the cos term because magnetic field is constant and area is constant. Number of turns of a coil is also constant. So we get E is equal to minus n into ba d by dt of cos omega t. What is the differentiation of cos omega t? It is minus omega sin omega t. So we get E is equal to minus n into ba. Differentiation of cos omega t gives us minus omega sin omega t. Minus into minus becomes plus and we get the expression E is equal to n into ba omega sin omega t, or we can write it as E is equal to E naught sin omega t, where E naught is equal to nba into omega. The maximum value of EMF occurs when sin omega t value is plus or minus 1. So when do we get sin omega t values as plus or minus 1? With the angles 90 degree and 270 degree. So you can represent the EMF has its extreme values at 90 degree and 270 degree like this. We can even write equation of E as E naught sin 2 pi f into t, because we know that omega is equal to 2 pi f. So we have the equation E is equal to E naught sin omega t. In the place of omega, substituting 2 pi f, we will get E is equal to E naught sin 2 pi f into t. This is all about self-inductance, mutual inductance and AC generator. In the next session, we will learn a new chapter called alternating current. See you all in the next session. Until then, keep learning all of you. Thank you.